Next week in lab, we are doing a reaction where we are taking a look at the reaction of tin, metal, and copper 2 plus ions, giving me tin 2 plus ions and copper metal. We are looking to find out what the potential for this reaction is, and we can come up with an E0 potential for this particular reaction. But my question to you is, how can we possibly be getting an E0 potential for this reaction when we are not under standard conditions, right? That 0 is supposed to mean that we are under standard conditions. But if we take a look at, again, the Nernst equation, E is equal to E0 minus RT over NF ln Q, right? So now when I take a look at Q, Q is equal to the products divided by the reactants. So if Q is equal to the tin 2 plus concentration divided by the copper 2 plus concentration, that's equal to 0.1 divided by 0.1, which is equal to 1, and the natural log of 1 is equal to 0. So in that case, E equals E0 minus RT over NF times 0. And so now we find that E does equal E0. So even though we're really looking at E here, we can assume that it is equal to E0 because these two concentrations are equal to each other. As this reaction goes on, however, we can find that that will not be the case, right? Just like we saw with the copper and the zinc, as the tin 2 plus increases and the copper 2 plus decreases, eventually the tin 2 plus gets so high and the copper 2 plus gets so low that Q becomes a significant value such that this whole ending piece over here is equal to E0, and then E will become equal to E0 minus essentially whatever that value is for RT over NF, and it will equal E0, so you end up with a potential of 0 volts, just like we saw with the copper zinc system before. I should also mention that the Nernst equation can be abbreviated a little bit. If we are at 298 Kelvin, then E will equal E0 minus 0.0592 over N times the log, the base 10 log of Q. And the reason that we can say that this is true is because we have a bunch of constants. R is a constant, T, because we're at 298 Kelvin, T is a constant, F, Faraday's constant, is a constant, and so we can just leave N in as a variable. And then we've also converted the natural log to the base 10 log, and so when you take all those constants together, you find that the natural log converts to the base 10 log, and your constant now is 0.0592.